In the context of outdoor electrical equipment, tombstones refer to a specific type of cover or enclosure designed to safeguard electrical connections from the elements and offer a secure mounting point for cords and plugs. These are generally constructed from weather-resistant materials, such as durable plastics or metals, and are characterized by a flat, rectangular shape, thus resembling a tombstone. The primary purpose of tombstones is multifaceted. Firstly, they provide protection from weather conditions. Tombstones shield electrical connections against rain, snow, and ultraviolet rays. This protection is vital for preventing corrosion and various forms of damage that could result from exposure to these elements. Secondly, they ensure secure mounting. Tombstones offer a stable mounting solution for cords and plugs, thereby guaranteeing a secure and reliable electrical connection. This secure mounting also plays a crucial role in preventing accidental disconnections, which could lead to power outages or potentially hazardous situations. Thirdly, they offer convenience. Tombstones are designed to facilitate easy access to and disconnection of cords and plugs whenever necessary, all while ensuring that the electrical connections remain shielded from the surrounding environmental conditions. Tombstones find widespread application in various types of outdoor electrical equipment that are not permanently wired. Common examples include pumps used for irrigation or water features, bird bath heaters designed to prevent freezing during colder months, extension cords used for temporary power supply, and power tools, particularly when these tools are operated outdoors. The use of tombstones offers a range of benefits. Firstly, they extend the operational lifespan of electrical equipment. This extension is achieved by safeguarding the connections from the harmful effects of the elements, which can cause degradation and premature failure. Secondly, tombstones enhance safety. They contribute to safety by minimizing the risk of accidental disconnections, which could lead to electrical hazards or equipment malfunctions. Thirdly, they provide convenience. The design of tombstones allows for easy and straightforward connection and disconnection of cords, making them user-friendly and efficient. When selecting tombstones for outdoor electrical applications, several factors should be taken into consideration to ensure optimal performance and safety. One crucial aspect is the material of construction. Tombstones should be made of materials that are specifically designed to withstand the rigors of outdoor environments. These materials should be weather-resistant, UV-resistant, and capable of enduring temperature fluctuations without degrading or becoming brittle. The size and shape of the tombstone should be appropriately matched to the cords and plugs that will be used with it. Ensuring a proper fit is essential for providing adequate protection and preventing strain on the electrical connection. The tombstone should also be easy to install and maintain. Clear and straightforward installation instructions along with a design that allows for easy access to the connections for maintenance purposes are highly desirable features. Finally, the tombstone should comply with all relevant safety standards and regulations. This compliance ensures that the product has been tested and certified to meet specific safety requirements, providing added assurance of its quality and reliability. In summary, tombstones are valuable components for outdoor electrical setups. They provide essential protection, enhance safety, and offer convenience, making them a practical and effective solution for managing outdoor electrical connections. When properly selected and installed, tombstones can significantly improve the performance and longevity of outdoor electrical equipment. Now, let's delve deeper into specific technical aspects related to outdoor electrical installations and safety. Ground fault circuit interrupters, commonly known as GFCIs, are a critical safety device designed to protect individuals from electrical shock. These devices constantly monitor the current flowing in a circuit and are engineered to quickly disconnect power if they detect an imbalance, which could indicate a ground fault. A ground fault occurs when electricity unintentionally flows through a path outside the intended circuit, such as through a person. GFCIs are particularly important in outdoor settings where the risk of electrical shock is elevated due to moisture and contact with the ground. The National Electrical Code, NEC, mandates the use of GFCIs in various outdoor locations, including receptacles that serve countertops, areas near pools and spas, and other damp or wet locations. This requirement is outlined in NEC Section 210.8. The typical trip threshold for a GFCI is 5 mA, meaning that tip will interrupt the circuit when it detects a current leakage of 5 mA or more. This rapid interruption occurs within a fraction of a second, minimizing the duration of any potential shock. Another vital aspect of outdoor electrical safety is proper grounding. Grounding refers to the establishment of a low resistance path to the earth, which helps to stabilize voltage and provide a safe route for fault current to flow back to the source. Effective grounding is essential for preventing electrical shock and minimizing damage to equipment in the event of a fault. Grounding systems typically consist of a grounding electrode, such as a ground rod or ground plate, which is connected to the electrical panel and other metallic components of the electrical system. The NEC specifies detailed requirements for grounding systems in Article 250. These requirements cover the size and type of grounding conductors, the installation of grounding electrodes, and the bonding of metallic components to ensure a continuous ground path. Regular inspection and testing of grounding systems are crucial for verifying their integrity and effectiveness. A ground resistance tester can be used to measure the resistance of the grounding electrode to ensure that it meets the requirements specified in the NEC. Overcurrent protection is another fundamental aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow, which can result from overloads or short circuits. Overloads occur when a circuit is subjected to a current that exceeds its rated capacity. Short circuits, on the other hand, occur when there is an unintended low resistance path between 2 points in the circuit, leading to a rapid and uncontrolled flow of current. Circuit breakers and fuses are designed to interrupt the flow of current when an overload or short circuit occurs, preventing damage to equipment and reducing the risk of fire. Circuit breakers are resettable devices that can be tripped manually or automatically in response to an overcurrent. Fuses, on the other hand, are one-time use devices that must be replaced after they have blown. The selection of appropriate overcurrent protection devices is crucial for ensuring the safety and reliability of electrical systems. The NEC provides detailed guidelines for selecting the correct size and type of overcurrent protection devices based on the ampacity of the conductors and the characteristics of the loads being served. These guidelines are outlined in Article 240 of the NEC. Surge protection is also an important consideration for outdoor electrical equipment, particularly in areas prone to lightning strikes or power surges. Power surges are transient overvoltage events that can damage sensitive electronic equipment. Surge protective devices, SPDs, are designed to divert surge current away from protected equipment, thereby preventing damage. SPD are available in a variety of forms, including whole-house surge protectors, which are installed at the main electrical panel, and point-of-view surge protectors, which are plugged into individual outlets. The selection of appropriate SPD depends on the voltage and current characteristics of the electrical system, as well as the sensitivity of the equipment being protected. The NEC provides guidance on the selection and installation of SPD in Article 285. Wiring methods for outdoor electrical installations must be suitable for the environment in which they are installed. Outdoor wiring is exposed to a variety of environmental factors, including moisture, sunlight temperature fluctuations, and physical damage. Therefore, it is essential to use wiring methods that are specifically designed for outdoor use. Common wiring methods for outdoor installations include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and non-metallic conduit. The type of wiring method selected depends on the specific application and the level of protection required. Direct burial cables are also commonly used for underground installations. These cables are specifically designed for direct burial in the earth and are resistant to moisture, corrosion, and physical damage. The NEC provides detailed requirements for outdoor wiring methods in Chapter 3. These requirements cover the types of wiring methods permitted in different locations, the installation of wiring in conduit, and the protection of wiring from physical damage. Electrical enclosures used in outdoor installations must be weatherproof and suitable for the environment in which they are installed. Electrical enclosures are designed to protect electrical equipment from the elements, including moisture, dust, and physical damage. Weatherproof enclosures are specifically designed to prevent the ingress of water and are typically rated for outdoor use. The National Electrical Manufacturers Association (NEMA) publishes standards for electrical enclosures that define the level of protection provided by different types of enclosures. NEMA 3R enclosures are suitable for outdoor use and provide protection against rain, sleet, and snow. NEMA 4 enclosures provide a higher level of protection and are suitable for use in areas that are subject to splashing water or hose-directed water. NEMA 4X enclosures provide the highest level of protection and are suitable for use in corrosive environments. Proper installation and maintenance of outdoor electrical equipment are essential for ensuring safety and reliability. Electrical equipment should be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. Regular inspections should be conducted to identify any signs of damage or deterioration. Damaged equipment should be repaired or replaced promptly. All electrical connections should be tight and corrosion-free. Overloaded circuits should be avoided. Extension cords should be used sparingly and should be properly sized for a load being served. Finally, it is important to educate individuals about electrical safety. People should be aware of the hazards associated with electricity and should know how to prevent electrical accidents. They should also know how to respond in the event of an electrical emergency. Electrical safety training should be provided to employees who work with electrical equipment. Homeowners should also be educated about electrical safety through brochures, websites, and other educational materials. Here's a discussion on specific types of outdoor electrical equipment and their safety considerations. Pool pumps are commonly used to circulate water in swimming pools and spas. These pumps are typically powered by electric motors and are subject to stringent safety requirements. Pool pumps must be GFCI protected to prevent electrical shock. The NEC requires that all receptacles serving pool pumps be GFCI protected. Pool pumps must also be properly grounded to provide a safe path for fault current flow back to the source. The grounding system must comply with the requirements outlined in Article 680 of the NEC. Pool pump motors should be inspected regularly for signs of damage or deterioration. Damaged motors should be repaired or replaced promptly. Extension cord should not be used to power pool pumps. If an extension cord is necessary, it should be properly sized for the load being served and should be GFCI protected. Landscape lighting is used to illuminate outdoor areas for aesthetic and security purposes. Landscape lighting systems typically consist of low-voltage lighting fixtures that are powered by a transformer. Landscape lighting systems must be installed in accordance with the requirements outlined in Article 411 of the NEC. Low-voltage landscape lighting systems are generally safer than line-voltage systems because they operate at a low voltage. However, even low-voltage systems can pose a shock hazard if they are not properly installed and maintained. Landscape lighting fixtures should be weatherproof and suitable for outdoor use. Wiring for landscape lighting systems should be buried underground or protected by conduit. Transformers for landscape lighting systems should be installed in weatherproof enclosures. Holiday lighting is commonly used to decorate homes and businesses during the holiday season. Holiday lighting systems can pose a significant fire hazard if they are not properly installed and maintained. Holiday lighting systems should be inspected regularly for signs of damage or deterioration. Damaged lights should be repaired or replaced promptly. Extension cords should be used sparingly and should be properly sized for the load being served. Extension cords should not be overloaded. Holiday lights should be turned off when not in use. Temporary electrical power for outdoor events requires careful planning and execution to ensure safety. Events such as concerts, fairs, and festivals often require temporary electrical power for lighting, sound systems, and other equipment. Temporary electrical power systems must be installed in accordance with the requirements outlined in Article 590 of the NEC. Temporary electrical power systems must be GFCI protected. Wiring for temporary electrical power systems should be protected from physical damage. Equipment used in temporary electrical power systems should be weatherproof and suitable for outdoor use. A qualified electrician should be hired to install and maintain temporary electrical power systems. Portable generators are often used to provide temporary electrical power in remote locations or during power outages. Portable generators can pose a variety of hazards if they are not used properly. Portable generators produce carbon monoxide, a deadly gas. Generators should be operated in a well-ventilated area, away from windows and doors. Portable generators should be properly grounded to prevent electrical shock. Extension cords used with portable generators should be properly sized for the load being served. Portable generators should be turned off and allowed to cool before being refueled. Electric vehicle charging stations are becoming increasingly common as electric vehicles gain popularity. Electric vehicle charging stations require a dedicated electrical circuit and must be installed in accordance with the requirements outlined in Article 625 of the NEC. Electric vehicle charging stations must be GFCI protected. The charging station should be installed in a location that is convenient and accessible to the vehicle. The charging station should be protected from physical damage. A qualified electrician should be hired to install electric vehicle charging stations. Lastly, emergency procedures and preparedness are crucial for handling electrical incidents effectively. In the event of an electrical shock, it is important to disconnect the power source immediately. If it is not possible to disconnect the power source, use a non-conductive object, such as a wooden broom handle, to separate the person from the electrical source. Call emergency services immediately. Administer first aid, including cardiopulmonary resuscitation (CPR) if necessary. In the event of an electrical fire, disconnect the power source immediately. Use a fire extinguisher that is rated for electrical fires. Call emergency services immediately. Evacuate the area. In the event of a power outage, turn off all unnecessary electrical equipment. Use flashlights or battery-powered lanterns for lighting. Avoid using candles as they can pose a fire hazard. Do not open the refrigerator or freezer unnecessarily. Stay informed about the cause of the power outage and the estimated time of restoration. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work or safety concerns. Strict adherence to safety guidelines, regular maintenance, and professional inspections are essential for maintaining a safe and reliable outdoor electrical system.